when we talk about space, space would be nothing but any three-dimensional region. Simply remember that this is one thing. So any three-dimensional region around us. So that is nothing but basically space. But here we are using the word space technology. So space technology means what is that space that we are going to discuss here. Okay, so here we are going to discuss about the space with respect to Earth. Okay, so with respect to Earth, and if you see in Earth, so if this is the Earth, so we can categorize the space of the Earth into two ways. Okay, so Earth space can be categorized into two ways. So one would be like, let's say, outer space, and other would be inner space. Outer space and inner space. So these are the two types of space that we can see with respect to Earth. Okay, so remember this thing. So now here with respect to space technology, we'll be considering mostly with respect to the outer space. Okay, now we have to understand what does this outer space refers to and where does it would be located. So that thing is another important thing that we have to understand. So now just have a look and try to recollect some important aspects related to atmosphere. So just assume that this is the surface of the Earth. This is the Earth's surface. This layer represents Earth's surface. Okay. Now, Earth will have an atmosphere. It is well known fact that Earth has some atmosphere. So atmosphere refers to thin blanket of air that surrounds the Earth. So that is nothing but atmosphere. So now, Earth can be vertically divided into various layers. Okay, so can you just bring up those layers? Okay, good. So troposphere is one thing. So troposphere, if you can recollect, what would be the distance to till the troposphere exists? 0 to 29. Okay, so generally to say like on an average we can say over the poles and over the equator likewise. So on an average if we say 13 to 18 kilometers would be the range where we can see the troposphere. Okay, so let's take for our convenience let us make that as 20 kilometers. I'm making it so that you can remember easily. Okay, so 13 to 18 or 20. Okay, so like this. Then second layer. So what's the second layer? It is stratosphere. And when we talk from the perspective of stratosphere, so it extends up to a distance of 50 kilometers. I am rounding it off so that you can remember easily. Okay, then next important layer that we will have, that would be good. So that is mesosphere. So this we can take up to 80 to 100 kilometers. Okay, so make it 80 kilometers. Okay, then beyond this we will have thermosphere and then exosphere. Okay, I hope you have recollected the basic layers of atmosphere now. Now let's try to understand. So beyond this, it is nothing but like we will have up to 10,000 kilometers, and then there it goes beyond that. Okay, so now in thermosphere we will have a line. So around, let's say for example, if we say from the perspective of this, around roughly around 100 kilometers. So we will have a line, we will have a boundary that demarcates the inner space of the Earth as well as outer space of the Earth. So that line would be known as Van Kerman line. Van Kerman line. Okay, so this Van Kerman line is nothing but it's the boundary that separates the inner space of the Earth with respect to the outer space of the Earth. Okay, so it roughly corresponds and it would be present around 100 kilometers distance. That means from the surface of the Earth. Okay, so that is one. Enough. You remember that this is the line that demarcates. So entire three-dimensional space, three-dimensional region that is located beyond this region, that is 100 kilometers, would be generally considered as outer space with respect to Earth. Outer space with respect to Earth. So space technology here we are going to deal, it deals with respect to beyond this 100 kilometers region. Okay, so remember, this is first thing that you have to remember. Okay, now when we talk from the perspective of the outer space, so the outer space would be generally made up of various celestial bodies, or in simple fashion to say, like there would be a lot of celestial bodies, or these celestial bodies are also generally said as like heavenly bodies because they will be present in this space. Okay, so make it heavenly bodies. So can you name some celestial bodies that are present in this space, outer space of the Earth? Yes, good. So sun, good. Then said moon, then yes. So name something, says Mars, Jupiter. What are Mars, Jupiter, all those things? Yes, good. So planets. Okay. So we have planets. And apart from that, we'll have, yes, good, asteroids, meteoroids, asteroids. So there are nothing but celestial bodies that would be present in the outer space of the Earth. Okay, so remember that. Now, if you see some of the celestial bodies, some celestial bodies would be colossal, like think about the stars like sun. So they are very large, and compared with these asteroids, they would be small. Compared with sun, like let's say planet like Earth, it would be small. Okay, so that means in this space there would be some large celestial bodies and there will be some small celestial bodies. So now what will happen with respect to this? So if we talk from the perspective of this, so we will have some, let's say, large celestial bodies. Let us take, I'm taking an example of, let's say, sun. Sun is, let's assume that it is one large celestial body. Okay, so if we take another example of small celestial body compared to this, let's say, let's take up it as an Earth. Okay, so Earth. So usually what will happen means a celestial body will have a gravitational pull of attraction. Okay, so usually it exerts some sort of gravitational pull of attraction, large celestial body. Okay, so when it exerts some gravitational pull of attraction, and when other celestial body is just floating in this space, then obviously when these two forces come in contact, so then obviously this, where this small celestial body, it starts orbiting in a curved path. It starts orbiting in a curved path around this particular large celestial body. Okay, so here you remember sun, like sun is large celestial body. Okay, and then the earth, which we are talking with respect to small one, earth is a small celestial body, or we can say object that is orbiting around this large celestial body. Okay, and can you see that there is a path around which this earth is rotating? So there is path. So the path in which the object orbits around a celestial body is known as orbit. Usually this orbit would be a curved path. So in simple fashion to say, orbit is nothing but the curved path around which a small celestial body rotates or revolves around the large celestial body. So that is one thing. So orbit. So then, now if we see from the perspective of this, the earth is orbiting. So the object that is orbiting is known as satellite. It is known as satellite. Okay, remember that. Okay, so basic thing is that sun, earth. So earth is the satellite for sun. And what is the path that is followed by the earth? It is a kind of curved path. So the curved path followed by or the curved path that is used by the satellite is nothing but orbit. Okay, so these are some basic aspects that you have to understand. So then, now this satellite, it can be this satellite. Can this satellite be a natural satellite? So that means these satellites can be natural satellites, or these satellites can be artificial satellites. They can be natural or they can be artificial. Let's say, for example, moon for Earth is a natural satellite. Like, let's say, for example, Earth here in this case, Earth is a natural satellite for Sun. In the similar fashion, for different planets, there would be different satellites. Okay, like moons, they will be different. So, like, they are natural satellites. And in the similar fashion, we will have some artificial satellites that we will send to the space for various purposes. Okay, now assume that if an artificial satellite has to be sent to the space, then there should be a vehicle that will carry this from Earth's surface to this outer space. So now you remember from the perspective of this that this artificial satellite would be carried to the outer space by a vehicle. Okay, the vehicle that carries the artificial satellites from Earth's surface to this outer space is nothing but satellite launch vehicle. Satellite launch vehicle. Okay, so then when there is launch vehicle, that means when there is a vehicle that carries this, so there would be some mechanism associated with that. So every launch vehicle will have certain structure mechanism. So every vehicle will have some sort of propulsion system. Propulsion system. Propulsion system. Actually, what do you mean by propulsion? Propulsion means the force or thrust that is exerted so that an object can move. Let's say, for example, if you are starting a bike, so bike will have a propulsion so that it starts and it moves likewise. So in the similar fashion, here also a satellite launch vehicle also will have a propulsion system. Okay, so that is one important thing that you have to understand. That means every satellite launch vehicle would be made up of an engine, and this engine will have a specific propulsion system. Okay, so have you understand till here? Okay, so what is an orbit, what is a satellite, so what is a satellite launch vehicle, and what is the propulsion system, all those things, have you understood that?